Hello, I'm Mr. Bob, and welcome to my Algebra 1 review series. This video covers Chapter 10, Section 5, titled Factoring to Solve Quadratic Equations. By the end of this video, you will have reviewed recent lessons describing the methods of solving quadratic equations. You will review using the zero product property and solving by factoring. Finally, you will have reviewed the solving of a real-world problem requiring the solution of a quadratic equation. If you'd like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to this channel if you find this channel to be helpful. Thank you. Objective 1, Solving Quadratic Equations. In previous reviews, you solve quadratic equations by finding square roots. This method works if b equals 0. You can only solve some quadratic equations when b is not equal to 0 using this zero product property. So what is the zero product property? Well, according to what this statement is here, it says, for every real number a and b, if a times b equals 0, then a equals 0 or b equals 0. Example, if x plus 3 times x plus 2 equals 0, then x plus 3 equals 0 or x plus 2 equals 0. We're going to use that as we move forward. So example 1, using the zero product property. So I included the property statement here, zero product property. For every real number a and b, if a times b equals 0, then either a equals 0 or b equals 0. And the example here was if the quantity x plus 3 times the quantity x plus 2 equals 0, then either x plus 3 equals 0 or x plus 2 equals 0, one or the other. That's what this property says. So let's look at our problem. Here we have a problem just like it. It says right here, solve x plus 5, the quantity, times 2x minus 6 equals 0. It's exactly what we have here. X plus 3 times x plus 1 equals 0. It's the same thing. Two binomials multiplied together, okay? And it says that one or the other is equal to 0. So it says if that is true, so let's go ahead and do it. We have the equation written here, the quantity x plus 5 and the quantity 2x minus 6 equaling 0. So if we take each one individually, on the left-hand side, I'm going to write and have written x plus 5 equals 0, because that's what it says. Either one or the other has to equal 0, one of those statements. So I can do that. Or on the other side here, on the right-hand side, I can say 2x minus 6 equals 0. So using the zero product property, solve for x. If we solve for x on the left-hand side, x equals minus 5. We move the 5 to the right-hand side by subtracting 5 from both sides, and we get x equals minus 5. Or on the right-hand side over here, we move the 6 to the right-hand side of the equation, and we get 2x equals plus 6, and then we divide both sides by 2, we get x equal to 3. Okay, so now what that's telling you is that if the x here in the equation is equal to negative 5, this part is going to go to 0, and if the x in the right-hand side of the equation is equal to 3, then this side is going to, let me do that in red just to make a difference on you, right? Then this side is going to go to 0. And if either of these go to 0, then this term goes to 0 right here. So now you know, in order for those to go to 0, the x has to be negative 5 or 3. Those are the solutions to this equation. And we can check it. Substitute minus 5 for x. So if we put a minus 5 right here, x plus 5 times 2x minus 6 equals 0. So if we put in a minus 5 in the first binomial, we have minus 5 plus 5 times 2 times minus 5 minus 6 equals, and it doesn't matter what it equals because the right-hand side says it's equal to negative 16, but guess what? The left-hand side says it's equal to 0, and 0 times anything is 0. So that side worked. The negative 5 works. If you do the same thing with the 3 over here on the right side of the slide, we're going to say the quantity x plus 5 times the quantity 2x minus 6 equals 0. Now we're going to substitute for the right part, the right side of this equation, and we're going to say, and we're going to replace the the x with a 3, and what you end up with is 6. If we put a 3 here where the x is, you get a 6 minus 6, which, by the way, ends up being 0. And so it doesn't matter that 3 plus 5, because you put a 3 for the x on the left-hand side. 3 plus 5 equals 8, but 8 times 0 is equal to 0. So in either case, those two numbers are the solution to that problem, the quantity x plus 5 times the quantity 2x minus 6 equaling 0. We've solved that quadratic equation. Okay, example 1, check your understanding. So go ahead and pause the video and try these, and when you come back, we'll work them together. But you see, it says here, using the zero product property. So that's what we're studying right now, zero product property. Okay, I'll wait for you. Okay, let's get going. Let's do problem A. So using the zero product property, it says x plus 7 times the quantity x minus 4 equals 0. So that tells us that either one of those terms, either binomial, must be equal to 0 for this statement, this expression to be 0, all right? So we're going to go ahead and try and solve. Let's find out what the values are for x. So in the first one, we have the quantity x plus 7 equals to 0. And given that, in order for that to be true, x has to be equal to, we're going to take x, we're going to add 7 and subtract 7 from each side. Okay, and these two will cancel, and we're going to get x equals negative 7. So if x were a negative 7, that would be 7 minus 7 would be equal to 0. Seems pretty straightforward. How about the other one? We have x minus 4 equals 0. Well, all we have to do is solve for x, and we're going to get x equal to 4 because we moved the 4 to the other side. X equals 4. And that's the answer. If you put a 4 in here, in both x's here, you're going to get a 0 in this section right here. You'll get a 0. And here you'll get 11. If you put 7, a negative 7 in, you're going to get negative 7 plus 7. You're going to get a 0 on the left-hand side, which will 0 the terms, and you'll end up with 0 anyways. So that's very self-evident, I think it should be. Let's do the next one. Let's do B. B says we're going to do the same thing. We're going to say 3y minus 5 is equal to 0, or y minus 2 has to be equal to 0. So if I solve on the left-hand side, I'm going to get 3y equals 5. I'm going to divide both sides by 3, and I'm going to get y is equal to 5 thirds. And the other alternative is, so if y were 5 thirds in the first expression up here, the first binomial, that term would go to 0. And if we do the second one, we're going to say y is equal to 2. So if y is equal to 2, you can see, in this case, 2 minus 2 right here, 2 minus 2 is equal to 0. So that's what zeroes out this binomial. So those two are solutions to this quadratic expression. Okay? Finally, at the end, 6k plus 9 equals 0, or 4k minus 11 equals 0. Solving the first one, we have 6k equals minus 9 divided by 6, because I'm going to say, and then we have k is equal to minus 9 divided by 6, and that, or we could say that that is also 3 halves. We can reduce that, simplify that term, 3 halves. And then the other one, 4k minus 11, so 4k minus 11 equals 0. 4k is equal to 11. k is equal to 11 over 4. There's the solutions. Okay, example 2, solving by factoring. So what we're going to do now is we're going to take this quadratic equation right here. It's the x squared minus 8x minus 48 equals 0. And they want us to factor it. Well, if you'll find something interesting here, that when we factor this quadratic equation right here, we end up with exactly the types of terms that we ended up in the previous slide, where we had the two binomials that we could multiply together and get 0. One of them has to be 0 to get, and then by finding this one of these being equal to 0, we can then determine, and the other one also, we can determine where the parabola crosses the x-axis, and that's what we're trying to find, is the solution to this quadratic equation. So given what we have now, we just have to be able to find out, how do we get this negative 12 and the positive 4 in here? Well, we do that by looking at, and we've done this in the past, by looking at the quadratic equation and then looking at the c and the b term. We see that the c term is 48. It's negative 48. And for it to be negative 48, that means that the two factors that have to multiply together that we're going to use to come up with this negative 8 for the b term, one has to be positive and one has to be negative. They can't both be positive or negative, because if they do, you'll get a positive 48, and we need one positive and one negative. And according to the rule here, since the b term is negative, that means that the larger of the two factors of 48, the larger one must be the negative term, because you're going to subtract one term from the other. And if you have a negative term, then you subtract a larger positive term, you're going to end up with a positive number, right? So we're going to go ahead and make sure that when we look at these factors, we're going to find the factors that will give us negative 8. And so what are the factors of 48? We have 1 times 48, all right? We have 2 times 24. What else do we have? We have 4 times 12, right? So given that, we can say, well, 4 and 12. Now look at, if we make the negative 12 and a positive 4, we're going to get exactly what we want, because if multiply them together, we're going to get negative 48. I could have said negative, right? Put a negative here and put the negative on that one. In fact, it probably would have been good to do that. So I have negative 12 and a 4. So I'm going to go over here and I want to substitute into my equation, my binomials, a negative 12 and a 4. And now I know that when I multiply these together, I'm going to get negative 48. And when I add these two together, I'm going to get negative 12 plus 4. It's going to be negative 8. So there's my two binomial terms. And now I can solve for x. I know that one of these, or both, but one of these has to be equal to 0 when you add up the x and the value inside the binomial. So given the first one, x equals minus 12, we know that x has to be x minus 12 is 0. We know that x has to be equal to 12. Or given x plus 4 equals 0, we know that x must equal to negative 4 for it to be 0. So those are the solutions to our quadratic equation, and the place where the parabola crosses the x-axis. Those are the solutions. So the parabola will cross the x-axis at positive 12. If I draw it, I'm going to say it's 12 and negative 4. So we're going to say that, let's see, it's going to cross here. Negative 4 is going to probably come somewhere like that, right? So here's going to be like the 12 over here, and here's the negative 4 down here. So there would be like the 2 points. So that's how somewhat like that. Not exactly, but you get the idea. Okay, example 2, check your understanding. Go ahead and take a moment and pause the video and try this yourself. When you come back, we'll work it together. Okay, I'm sure if you're going to pause the video, you've done that and you're back. So let's take a look at this. The equation they want us to solve, the quadratic equation, is x squared, right here, x squared plus x minus 12. So I've rewritten it, x squared plus x minus 12. And what do we have to do now? We have to factor it. This is by factoring, right? So to factor it, I'm going to just write down, we're going to put down some parens. And those parens are going to be equal to 0. And we know that it's x squared, with the a term is 1, so it means x, remember FOIL? This is the first, x squared, right? X times x. Now we have to figure out the two terms here that when added together are going to give us a 1. It's 1x. And 12 minus 12 is our c term. So whatever the two terms that we add together to get our b term, we have to multiply together to get our c term, negative 12. So what factors of 12 or negative 12 can we use that will get us, that will added together will be 1 and multiplied together will be negative 12? Well, if we start over here we can start with 1 times negative 12. And if you put a 12, can you put a 12 in here? I want a 1, right? What can I subtract a 1 in any form from 12 to get a 1? No, you cannot. So let's try another one. Let's try another set of factors would be 2 times negative 6. Okay. And also keep in mind that the negative sign here could switch. It could switch. And so 2 and 6. So if we can we take any combination of a 2 and a 6, negative or positive, and come up with 1? Can you subtract a 2 from the 6? From a negative 6, from a positive? No, they can never come together. However, 12, if we did 3 and 4, 3 and 4 gives us a 12, and 4 minus 3 gives us a 1. So we found our numbers. Now we just need to know whether they're positive or negative. Well, what is the rule? The rule was if it's a negative c term and a positive b term, then the terms have to be, one has to be negative and one has to be positive, the factors for the c term, and the positive term has to be the larger term. So if that's the case, the 4 is going to be positive, the 3 is going to be the negative term. Okay, so given that, I'm going to say, just write it in. I'm going to say negative 3 and plus 4. And now when we multiply negative 3 and 12 and 4 together, we get negative 12. And when we add 4 plus negative 3, we're going to get a 1. So that's it. Now we can solve for the values of x. We can solve this quadratic equation, and we can do that by saying x minus 3 equals 0. This is our zero product property. And or x plus 4 equals 0. And given that, x then equals 3, or x equals negative 4. And those are the two places that the parabola will cross the x-axis. Okay? Okay, example 3, solve by factoring. It's another factoring problem. They've thrown a little hook on it for you. So what did we start off with? It says solve 2x squared. Now the a term is no longer 1. It's not a 1, right? So minus 5x equals 88. So in order to solve this, the only way we know how to do that is we have to get to the zero product property, right? That we're learning here, or we've learned about now. And in order to do that, it means we have to get the entire expression. We need a quadratic expression that is equal to 0. In order to do that, we have the equation 2x squared minus 5x equals 88. What we're going to do then, I've rewritten it here, we're going to move the 88 from the right side to the left side. We're going to subtract 88 from both sides. So now we have 2x squared minus 5x minus 88 equals 0. So now we're in the correct form to factor this. Well, there's a number of ways of factoring it, and we'll talk about one. We learned them all in the last chapter when we reviewed that and when you studied it in class with your teacher. Anyways, so we have to have something that's going to give us a 2 and a 1 on our x terms, because there are only two factors for a 2 which is a prime number, is 2, and it's is 1, right? Itself and 1. So we have to use the 2 and the 1. That's given. So now we need two terms for the binomial that are going to be able to multiply to 88 and add to 5, negative 5 in our case. But so what are we going to do? How do you find that out? Well, we went over some of the methods, but one of the ones for sure we can do is we just factor out the primes. Because the interesting thing is, let's see where the prime numbers are. And keeping in mind that you're pretty much going to use them all in some form or another, because you have to get 88 when you're done. So if you take 88, okay, and you take the primes out, you get a 2 and you get 44. And you take a prime out, you get 2 and you get 22. And you take a prime out, you get 2 and 11. Well, now you're stuck with all primes, right? Well, the 11 has to be used. It's part of the 88. You can't not use it. And you have to use all these 2's. Now you can multiply the 2 times the 11 and the 2 times the 2 and get 22 and 4. Well, 22 and 4 aren't going to give you an 11 or a minus 5 in any way. So, but if you use them as we're looking at them, 11 times 2 times 2 times 2 is 8. 11 times 8 is 88. I think we found our numbers right here. So now the question is it a negative 11 or a positive 11? Because it's a negative 88, and one of them has to be positive, and one of the factors has to be negative. And the 5 is negative, so that means what? That means that the larger term must be the negative. That's what we learned. But sometimes there's a hook there, because you have this other term with the a term. With the a term, it's not 1 anymore. It's a 2 or a 5 or whatever it happens to be. Well, given that rule might switch. So you're just going to have to try it. So I say start off by trying, but you could set the 11 to positive, or let's say we set the 11 to negative, following the original rule. We set the 11 to a negative and the 8 to a positive. We're going to get 8 is negative 11, rather. We're going to get a negative 11 plus a negative 16. Well, let me rewrite it then. So it's going to be 2x, I'm getting a little confused myself, minus 11 times x plus 8. Well, when you do the FOIL on that, you're going to get a minus 11 and a plus 16. If minus 11 and a plus 16 gives us what? Gives us a positive 5. Well, something to note here, that once you do that, when you realize that you've got a positive 5 and you're looking for a 5, all you need to do is change your signs. So now if I take it and I say 2x plus 11, x minus 8, what am I going to get? I'm going to get, this is an 11 here, 11 times x is 11x, and 2 times negative 8 is negative 16, and negative 16 plus 11 is negative 5. So that's your answer. So you get 2x plus 11 times x minus 8, and that equals 0. And then when you factor this, you end up getting, you take the 11 to the right-hand side and divide by 2, and you're going to get 5.5 for one of the x terms. And the other one, you're going to get an 8, because you took x minus 8 equals 0, and you found x to be equal to 8. Okay? Okay, example 3, check your understanding. You can go ahead, you're going to pause the video. At least I hope you pause the video and try it. Go ahead and do that. And you're solving x squared minus 12x equals negative 36. Give it a shot. See what you come up with. Okay, I'm assuming you paused, you tried it, you're back now, so let's go ahead and work it. So like the previous slide, we have where this quadratic expression is not equal to 0. So we have to, first off, make it equal to 0. And we're going to do that by saying x squared minus 12x plus 36 equals 0. Because we moved the negative 36 from the one side to the other side. Okay? So now we have a plus 36. So now we have to factor it. And we can do it the hard way or whichever way it is. Well, not really a hard way, but we just make some guesses because it's 36. And we pretty much know a lot of the factors right off the top of our head, don't we? So we know now that this is positive. And since this term is positive, what does it mean? It means that in order to get it, by multiplying two numbers and getting a positive number, either both your terms have to be positive or both have to be negative. Well, I see now that we're B term, we have to add it together and get negative. So the only way you can get a negative term by adding two positives or two negatives together is they have to be negatives. So we know that we're dealing with a negative term in each binomial. There is an A term is a 1. So we know now that we can just put an x in the first binomial and an x in the second one. We know they're both negative, so we're going to put a negative in the middle of both. We know they're both negatives. Now we just have to find the factors of 36 that when added together give us a 12. So what factors of 36 can give us a 12? Well, what are the factors? We have 1 and 36. We have 2 and 18. We have 3 and 12, right? We have 4. We can put 4 into 36. But let's skip all of the numbers now. Go right to this one. How about 6 times 6? That equals 36, right? So 6 is the answer. And what are the 6's? Well, it's -6 and a -6. Because -6 times -6 gives us a positive 36, and -6 plus -6 gives us a 12. So we're going to put a 6 here and a 6 here. And when we do this, it's kind of easy. X, if we pick the first one, x minus 6 equals 0. X equals 6. Well, they're both the same. So x equals 6 is the solution. Example 4, it's a real-world problem. So a diagram, and it's here on the slide, you can see the diagram, shows a pattern for an open top box. So you can imagine this is like a shoe box, right? It's an open top box without the lid, right? Open top box. And the sides are folded up to make that box. And here you see it right here in front of us. The folds are on the dashed lines. The total area of the sheet of material used to manufacture the box is 288 inches square. So what they're saying here is the distance from here to here and from here to here is the overall sheet of material that they're going to use. And they say it is equal to 288 inches squared. The height of the box is going to be 3 inches. They show that right here. The height of the box, and this cut right here. When you fold up this edge right here, and you fold up this edge right here, and they're both 3-inch cuts, when you fold them together, they're going to meet in a straight line vertically coming out of the paper at you, right? They'll meet. So that's the cut. That's the height of the box. It'll fold up to be 3 inches. Therefore, a 3-inch by 3-inch square is cut from each corner. And here's that 3-inch by 3-inch square right here. Okay, so find the dimensions of the box. And they give us x and x plus 2. So they're telling us that the width of the box is x and the length is x plus 2 inches. So let's find the dimensions of the box. Let x equal the width of the side of the box. And we have the x right here. So this is the width right here. X is the width right there. So then the width of the box is x, here's the x, plus 3 plus 3. Totally, it's x plus 6 right here. X plus 3 equals x plus 6. So that's the length. It's this side here that we know is x plus 2 pieces that we know are 3 each, but we still don't know how long x is, but we're trying to find that out. And then the length of the box, the length of the material, that they're saying measuring from here to way up here, the length of the material is x, right here, we got the x, plus 2. And here it is, x plus 2 right here, plus, just like we did for the other side, plus 3 plus 3. So x plus 2 plus 3 plus 3 is x plus 8. So these are our two terms. So the width of the box, the length times the width that we're talking about here. We said let the length equal x plus 8. We said let the length, the width right here, the width, the length, the width of the box equal x plus 6. So they're saying here the length times the width is equal to the area. And do we know what the area is? Yes. What is the area? The area is 288 inches squared. That's the area of the sheet that makes this box. So, and what are the factors for that area? Well, length times height. Well, the length was x times 6. X plus 6 was the width, rather. And the length was x plus 8. Length times width. X plus 8 times x plus 6. And that equals 288. So now we're going to multiply that together. We're going to multiply these two binomials together. Okay? And then, first of all, we're going to move the 288 over to the left-hand side. Excuse me, I was trying to get my left and right straight. To the left-hand side of the equation. So we're going to have x squared plus 14x plus 48 equals this. We move it. We have x squared plus 14x minus 240, because 48 minus 288 is 240. So now we can factor this. And that equals 0 now, right here. X squared plus 14x minus 240 equals 0. So now we're going to factor it. We're going to multiply to get this solution here, right? And when we do that, we're going to get x plus 24 times x minus 10. You just pick the easy one to start with. And we're 24 and 10. Somehow in your mind you can see a 14 real easily right there. So the first thing you would naturally do is jump to the 24 and 10 for the 240. And again, we know that it's a negative, so that means we have a positive and a negative term. Right? To get a negative C term, the B term is positive, so the larger term has to be positive. And here it is. 24 is the positive term. Negative 10 is the smaller term. And 24 times negative 10 is negative 240. And 24 plus negative 10 is 14. So when we do that, we end up, and that's the 14 right here. So when we do that, we have the two terms, x plus 24 equals 0, or x minus 10 equals 0. And that means that x equals negative 24, or x equals 10. So the only reasonable result is x equals 10. Because why? Because you can't have negative space. This is a real world problem, so you can't have a negative length or a negative width. Okay? So the positive term is the only term that makes sense here. And you have to do that when you're doing story problems for real world problems. You have to say, is that a real term? Can I have a negative? We talked about that before in our lesson. Can we have a negative time value? No, generally, where we're having a problem, we're measuring something through time. It's usually from 0 positive, right? So we have x equals 10, and therefore the dimensions would be 10-inch width, 12-inch length, and of course a 3-inch height. So if there's no questions, put them in the notes down in the comments. If you have a question, I'll try to get back on it for you. So let's go on to the next slide. Okay, example 4, check your understanding. Solve, it says. Well, right off the bat, we can tell you this is exactly the same type problem we just looked at. So if you have to back up the video and watch it a couple times and then come back to this, there's no harm in that to see how you do this. But go ahead and stop the video and try it. and when you come back, we'll do it together. Okay, so now you've had the time to try it. Let's see what we can come up with. So I'll read it off. It says, suppose that a box has a base with a width of x and a length of x plus 1 and a height of 2 inches. And it is cut from a rectangular sheet of material with an area of 162 inches square. Find the dimensions of the box. So the questions from the last slide, I left them here. Let x equal the width of the side of the box, and that means the width of the box is what? Well, looking at our numbers here, the width is x, so we have an x. We know the height of the box is 2, so it's plus 2 plus 2. That equals x plus 4. And the length of the box is x plus 1, so x plus 1 plus 2 plus 2, just like the width. Okay, and then that equals x plus 5. So those are our two terms. So let the length times the width equal the size of the sheet that we're dealing with here. And so that equals, so now we're talking about x plus 5 times x plus 4. Length times width. And that equals the material 182, I'll put it in, inches squared. Okay? 182 inches squared. So now we have to get this in a quadratic form that we can solve by factoring. And in order to do that, we have to multiply these terms out. So we're going to get x squared plus 9x and plus 20. Okay, and that equals 182. Now we have to get this to 0 on the right-hand side, so we have to subtract 182 from both sides. So now we have x squared plus 9x is equal to negative 162. 182 minus 20 is 62, and that equals 0. Okay, so now let's factor it. We need to come up with two terms that'll add up to 9 and multiply to 162. Well, I would say, and according to this, the terms have to be opposite in sign, and the larger of the two terms has to be positive because of the b term is positive. So let's start off with 162. 162, and I'm going to find some factors. 2 and 81. And 81 gives me a 9 and a 9. Well, I need a 9. Well, that's quite nice because if I take and multiply the 2 times the 9, I'm going to get 18. And I can have, the other term is the 9, right? So I can, 9 times 18 is 162. Or, excuse me, 162. And then I'm going to select the terms to be positive 18 and negative 9. I think we have it. So I'm going to write this as factored is equal to 0 as x and 18 and 9. Negative 9 and plus 18. Because 18 minus 9 is 9. 18 times negative 9 is 162. Given that, we're going to find x plus 18 equals 0 using the 0 product, right? So x is then equal to negative 18. And the other one, we have x, this was minus 9. X minus 9 equals to 0. And x equals 9. Well, we know from the last time the negative 18 can't work because it's a real world problem with real dimensions, and real dimensions on a box are not negative. They cannot be negative. So 9 makes sense in this solution. So we're going to have, and 9 is x, which is the width. Let x equal the width. So we're going to write here the length, or the width, or how you want to do it. We can say the width, w, is equal to 9. we can say length is equal to 10 and height is equal to 2. Okay, good job.